Hi, thanks for joining me today. I've got a pretty cool problem which you do not want to use calculus for. We want to find the minimum possible value of the square root of 58 minus 42x plus the square root of 149 minus 140 times the square root of 1 minus x squared. And x is a number between minus 1 and 1. And now you could do this by calculus, but it's going to be extremely horrible to do. If you want to have a go at this problem, pause the video now and give it a go for yourself, but I'm going to dive right in here. Now, it's not obvious what we want to do here, but the one thing that I do notice is that we have a 1 minus x squared here, and that suggests that maybe it's got something to do with sine theta and cos theta. So a natural thing to do here is just say let x equal cos theta. And also what helps suggest that is the fact that x is only between minus 1 and 1, which is the range of cos. So this thing here just becomes the square root of 58 minus 42 cos theta. And then this guy here is going to be plus the square root of 149 minus 140. Well, square root of 1 minus cos squared theta, well, that's square root of sine squared theta, which is sine theta. Now, you may have noticed that I didn't consider plus or minus there, and you can just check for yourself that x here is going to have to be a positive number if we're trying to minimize this. The reason for that is you can essentially just swap x with minus x, and that doesn't change the value of this, but it does, if x is negative, that makes this thing here bigger. So in other words, the value of x which minimizes this will be a positive number, and so therefore x is cos theta, and when I do the square root of 1 minus cos squared theta, it's sine of theta, because theta is positive. Anyway, okay, cool. So we have this here, but how on earth does this help? Well, the trick is to make an observation. I'm going to make an observation that 58 is 7 squared plus 3 squared. Okay, what about 42? 42 is 2 times 7 times 3. Maybe you can spot something there. We're going to do something similar with this guy over here. 149 is 10 squared plus 7 squared. And 140 is 2 times 10 times 7. Pause! I've decided to set up my own tutoring company to help you study maths at a top university. So if you like the way I explain things, go check it out. Let's get on with the video. Okay, so these are some interesting, seemingly random observations. Why are they important, or where have they come from? Well, again, it kind of comes from the fact that we're letting this be cos theta. So maybe it's got something to do with the cosine rule, and absolutely it does. So let's just quickly review the cosine rule. If we have an arbitrary triangle, a scalene triangle, let's say, and this angle here is alpha, and I label these sides A, B, and C, then a squared is b squared plus c squared minus 2bc cos alpha, and so therefore A is just equal to the root of this. And so what's really nice about this is this thing here, because of these observations here, this describes the side length of a triangle with side lengths 7, 3, and then the angle between the 7 and 3 being theta. So it would look something like this. If this is the side length 3, this is the side length 7, and this is the angle theta, what this thing here describes, let me just call it M, that describes the side length of that triangle there. Cool. Okay, what about this thing here? Well, we get something similar. Well, we're going to firstly use the fact that sine theta is the same as cos of 90 minus theta. Cool. So this is 149 minus 140 cos 90 minus theta. So this describes a triangle where you've got two side lengths. One is 10, one is 7, and the angle between them is 90 minus theta. And you can maybe guess where we're going to place this triangle. I'm going to place it here. So I'm going to place it here so that this angle here is 90 minus theta. Well, I've got the 7 side there. In fact, maybe I'll make this length a bit longer. So this is 90 minus theta, and this is the side length 10. And if I call this expression here n, that's talking about this side length of this triangle here. Cool. Now, what are we trying to do? We're trying to minimize the value of m plus n. And what do we notice about this? Well, this is a right angle. It's theta plus 90 minus theta. And so we're trying to minimize the kind of the sum of the side lengths of these two triangles. How do we do that? Well, choosing theta appropriately, we can make it so that m plus n looks like this hypotenuse of this triangle ABC. And so therefore the minimum value of m plus n is just the length of BC, and we can just apply Pythagoras' theorem there. So the minimum value of m plus n is the square root of 10 squared plus 3 squared, which is root 109, and that solves our problem. A pretty neat problem. You don't need to use calculus to solve this, but you do need to make some pretty nice observations. So hopefully this is, has tickled your fancy and you've enjoyed this solution. If you have, do just drop this video a like. It helps with the YouTube algorithm and shows me that you enjoy these sorts of videos. And if you're new to the channel, please do subscribe as well. Thanks for watching. I'll catch you in the next one. Have a great day.